Hello, welcome to KAJOS Consultants. My name is Joshua, and today I'll be taking you through some of the assumptions of the paired sample t-test. So this is a form of inferential analysis, and it is used to prove a hypothesis in research. In this case, the means of two measurements taken from the same individuals, objects, or related units are compared. So the purpose for undertaking or for carrying out this test is simply to nor determine whether there's a statistical evidence that the mean difference between paired observations is significantly different from zero. It is also worth noting that this is a parametric test, meaning that the normal distribution has to be there for you to run this analysis, and you can always go back to some of the videos that I have already done on our test for normality so that you can get more insights on the same. So the paired sample t-test can also be referred to as a dependent t-test. Another thing that you can also maybe say anonymous to this is a paired t-test. And the final one is also known as repeated measures t-test. So this particular test also represents a number of issues here, and I have three things or three aspects that are listed for this particular test. So one, it's a measurement that you take on two different times. E.g., there's a pre-test. Pre-test means you take a test or you run a test before, and a post-test score, which means this is a test that you do after a particular intervention in a given area. It can be a project, or maybe you want to reverse a certain trend that is worrying in a given area. So secondly, it is also a measurement taken under two different conditions. And here the condition that we have is a control and an experimental condition. So experiment is whereby you subject particular issues to maybe a certain laboratory test so that you can compare, then you get similar results. The next one is that can also be a measurement that you take from two sources of subjects or experimental unit. This one can be, for instance, you want to measure the hearing loss in the left and the right ears of a particular subject. The variable that we use here, we have a dependent variable and or the test variable, and this variable must be continuous and measured at two different times or for two related conditions or units. So that is one of the things that you really need to know on the variable that you apply for this case. On the other hand, it is being applied or it is being used for different reasons. One is for statistical differences between two time points. Second use for this is statistical difference between two conditions, and the conditions are highlighted above with the control and the experimental. Third one is when you want to know the statistical difference between two measurements. For example, the ophthalmologist want to know the difference between whether there's a measurement for the left and the right ear, and that needs to be determined. And finally, when there's a statistical difference between a matched pair. Some of the assumptions that you need to know before you undertake or you run this particular analysis is that there should be dependent scale variable, and the data should be randomly distributed. And third one, dependent variable should look approximately normal, and therefore that is the normal, a test for normality, and therefore no outliers for the dependent variable. That means there should be no extreme values when you are running that particular analysis. And in conclusion, it is also important to note that when you want to compare paired means between two independent groups on a continuous outcome that is normally distributed, should choose the independent sample t-test, and that is also here in my channel. You can always check for that when you want to run such analysis. Secondly, it is also important to note that to compare, when you want to compare unpaired means between more than two groups on a continuous outcome that is normally distributed, choose ANOVA, because this one only support a comparison of two. Only two groups can be compared. The third one, if you want to compare paired means for continuous data that are not normally distributed, you can choose the non-parametric will cost some signed ranks test, and this one will give you a better result for that. And the last one, if you want to compare paired means for rank data, choose the non-parametric will cost some signed ranks test for the same. So this is all about some of the assumptions that you need to know when you are conducting paired sample t-test. So kindly hit the subscription tab below, subscribe to this channel for more update on the same.